All right, so today we're going to take a look at the sum and difference identities from your formula sheet, and we're going to use them to simplify or verify some problems. We're going to use the addition formulas for tangent to simplify. Now, if you notice, there are two different versions of tangent of u plus v. In this particular problem, they want us to do tangent of s plus t. So I would suggest that since they provide us with tangent, we would use the formula that involves tangent. All right, we don't know anything about sine or cosine, so it would not make sense to use this one with sine and cosine. So let's stick with the one with tangents. So we know that that should be tangent of s plus tangent of t over 1 minus tangent of s times tangent of t. Now we just have to substitute with the values that were given above. So we have 2 plus 3 over 1 minus 2 times 3. And that would give us 5 over 1 minus 6, which is 5 over negative 5. And your final answer is negative 1. Number 2 will be similar to number 1 because it's subtraction this time. And again, we want to go with the formula that includes tangents. Don't go with the formula that has sines and cosines, since we were not told anything about sine and cosine of s or t. So for subtraction, we're going to do tangent of s minus tangent of t over 1 plus tangent of s times tangent of t. And then we just have to substitute using the values from above. So we have 2 minus 3 over 1 plus 2 times 3. And that gives me negative 1 over 1 plus 6, which is negative 1 over 7. And that would be your final solution. All right, moving on to number 2. This one is sort of like doing the problem backwards. We are going to try to look for one of the formulas that looks similar to the format of our given information. So I notice that I have tangents in the numerator and 1 plus tangents in the denominator. So they look similar to these last two formulas, but if you notice that there's a plus sign here and there's a plus sign here, that means don't use that formula. We're going to use this one. So we are given the expanded version, and now we need to condense. And so think of the right side as the expansion, and we need to condense in order to get to the left side. Right, so we know that this is tangent of two angles subtracted, and what are the two angles? 70 and 10. So it's really tangent of 70 minus 10 degrees, which simplifies, of course, to tangent of 60. All right, but we need to simplify and figure out what that answer is. So think back to your unit circle, and 60 degrees would be in quadrant 1. And in this case, we would have square root of 3 over 2 as our y coordinate. And we would have 1/2 as our x coordinate. And so tangent would be y over x, which would be root 3 over 2 all over 1 over 2. And so we can cancel out our 2's, and we are left with root 3. Number 2 would be a great one to verify with our calculators. So first, we would double check that we are in degree mode. We could just type in this exact problem. And so I just did alpha y equals, so I get a numerator and a denominator. And I'm going to do tangent of 70. And then make sure you close your parentheses, minus tangent of 10. And again, make sure you close your parentheses. And then we're going to move down to the denominator, and we're going to do 1 plus tangent of 70, close your parentheses again, times tangent of 10 degrees. And then if we hit enter, we can verify what is tangent of 60, and that should be the same thing as what we just got, which it is. For problem 3, we're going to prove that the following equation is an identity. And just like before, we're going to work only on one side of the equation. And I would suggest working on the left side since that looks more difficult. So look at the first part. It says sine of a minus b. We're going to use one of our sum and difference identities from the formula sheet in order to expand and then hopefully get to sine A cosine of B. And then we'll do the same thing with the sine of A plus B. All right, so let's look back at the identity sheet. So for sine of A minus B, we're going to use this formula because it fits the pattern of sine of two variables being subtracted. And then when we get to the second part of the identity where it says sine of A plus B, we're going to use this next formula above it, which is sine of A plus B. So we're just going to change our V's and U's into A's and B's, and then hopefully it simplifies really nicely. All right, so sine of A minus B expands to sine of A times cosine of B minus sine of B times cosine of A. And I'm just going to put that in a bracket just so I can separate it. And I'll just change colors so that you can see sine of A plus B expanded. So we know we're going to add whatever we get for this expansion. And so that would be sine of A times cosine of B plus sine of B times cosine of A. All right, so now I'm adding, and I'm going to look for like terms. And so my like terms, I have sine A cosine of B. They're both positive, so I have two of those. And then my other like terms, I have sine B cosine of A. One of them is negative, one of them is positive, so they actually cancel out. And then now I do have the same thing on both sides. So therefore, I know that this identity is actually true. All right, so we're going to do something similar for number 4, but this time we have a cosine. So we need to look at what's cosine of something plus something. So let's go back to our formula sheet. So for cosine of something plus something, we're going to use this cosine of u plus v formula, and we're just going to change the u's and v's into thetas and pi over 4s. And then for the second part of the problem, we're back to the sine of an angle minus another angle. So we're going to use sine of u minus v and just replace the u's and v's with thetas and pi over 4s. Using those formulas that we just identified, we're going to expand cosine of theta plus pi over 4 into cosine theta times cosine of pi over 4 minus sine theta times sine of pi over 4. And I'm just going to put those in brackets so we can separate. And I'll switch colors so that we can do the sine of theta minus pi over 4. So that expands to sine theta times cosine of pi over 4 minus sine pi over 4 times cosine of theta. And obviously we're working just with the left side of this equation, hoping that it equals 0. All right, so now at this point, we do want to think back to our unit circle because pi over 4 is a specific angle, not just a generic variable. And so we know that pi over 4 has a cosine of root 2 over 2 and a sine of root 2 over 2. And so we can replace all of these cosine and sines with root 2 over 2. So once we do that, now I have root 2 over 2 times cosine theta minus root 2 over 2 times sine of theta plus root 2 over 2 sine of theta minus root 2 over 2 times cosine of theta. And now I'm going to look for my like terms. So in my like terms, I have a positive root 2 over 2 and a negative root 2 over 2, so those are going to cancel out. And then in my other set of like terms, I've got a negative root 2 over 2 and a positive root 2 over 2 times sine of theta. And so again, those will cancel out. So I do get 0 equals 0. And that means that my identity is in fact true. All right, for my last problem, it does say to simplify. So one way to look at this problem is to notice that we have sine of two angles being subtracted. We have cosine of two angles being added, sine of two angles being added, and cosine of two angles being subtracted. Now, we could expand each of these four expressions, but then you're going to get a very large expression, which you're then going to have to multiply and then add, and it just seems like a complicated mess. So we don't want to do that. If it seems like you're going in a direction where the problem is going to get way too difficult, you're probably going in the wrong direction. So instead, let's look at this as the already expanded version. And let's figure out what's going on. So I have an expression here, pi over 3 minus t, and I have that same expression over here. So that could be one particular angle. And then I have another expression that is pi over 3 plus t and pi over 3 plus t. That could be a different angle. So if you think of it that way, this is really just sine of u times cosine of v plus sine of v times cosine of u. And then we just need to look at our formula sheet and see how we can condense that. So let's go back to the formula sheet. All right, so we're looking for sine of u times cosine of v plus sine of v times cosine of u. So I definitely need a plus sign in there, and it doesn't match up with this one, but it does in fact match up with this one. So this we're going to use down in number 5. So really this is just sine of u plus v. All right, now what is the angle u that we've identified? So this is sine of pi over 3 minus t. And what is the v that we have identified? And that's pi over 3 plus t. And so now you can simplify even further. So we have pi over 3 plus pi over 3, that's 2 pi over 3. And then we have a minus t and a plus t that cancels out. So we're just left with sine of 2 pi over 3. Now that is something that's on our unit circle. So if you go back to thinking about or finding one of our completed unit circles, we're just going to draw it out here. If we went 2 pi over 3, that would give us a pi over 3 as a reference angle. And so that's a 60-degree angle. And that's root 3 over 2 and 1/2. Now make sure you put a negative there for your x-coordinate. But in this case, we only care about sine of 2 pi over 3. And so that is equal to root 3 over 2. So this huge, long expression that we had originally just simplifies down to root 3 over 2. All right, and that's it for today. So if you have any questions, make sure you ask your teacher.